Welcome to The Explainer. Today, we're going to jump in our time machine and head back to 2018. We're looking at a single research paper. And I know, that might sound a little dry, but trust me, this paper, Improving Language Understanding by Generative Pre-Training, is the quiet little spark that lit the fuse for the entire modern AI explosion.
You know, way before ChatGPT was a thing anybody had heard of, a team at OpenAI put out this idea, and it basically changed everything. And it all started because they were trying to solve this one massive problem that was just holding the entire field of AI back.
All right, so let's dive right in. What was the big problem? The single biggest roadblock for AI back then was data. But not just any data. We're talking about a very specific kind of data that was super expensive and incredibly hard to get. So check this out. In the old days of AI, if you wanted to teach a model a new trick, say understanding movie reviews, you had to build a special model just for that, from scratch. And each one needed this huge, custom-built data set that humans had to label by hand. It was literally like building a brand new brain for every single task. I mean, you can imagine how slow and crazy expensive that was. So the big idea, the new idea was, what if you didn't have to? What if you could build just one general model first? Okay, so here's the bottom line. These AI models, they needed mountains of this hand-labeled data to learn anything useful at all. The problem was, for most of the really complicated stuff, like common sense reasoning or understanding subtle language, that perfect, clean data just didn't exist. Not nearly enough of it anyway. AI had basically hit a brick wall.
So the big question is, how did they get around this data crisis? Well, the researchers came up with this brilliantly simple two-step process that was honestly revolutionary. And this, right here, this is the idea that changed everything. Step 1, you just let the model learn about the world by itself. You give it a huge library of text, no specific instructions. You just let it read and learn the patterns of grammar, facts, logic, all of it. Then, step 2, once it's super well read, you take that really smart model and you fine-tune it with just a tiny little set of labeled examples for your specific task. You see the difference? It's like getting a full, well-rounded education first, instead of just cramming for one specific test. So let's break that down. Think of this first step, this generative pre-training, as the model basically going to the world's biggest library and just reading. It's not studying for anything in particular, it's just absorbing everything, learning how words connect, how sentences are built, and even picking up on world knowledge, all by just trying to predict the next word in a sentence, over and over and over again.
And then comes step 2, fine-tuning. This is where you take your incredibly smart, well-read model and you give it a very specific job to do. You show it just a handful of examples, maybe for something like sentiment analysis, and all that general knowledge it soaked up from reading, it gets focused, it gets adapted to crush that one specific skill. All that deep learning gets transferred with almost no new effort. It's incredibly efficient.
Now, this whole two-step thing sounds great on paper, right? But to actually make it work, to pull it off, it required two very specific ingredients that had, just become powerful enough to do the job.
So what were these secret ingredients? Well, first was the architecture. The researchers used a model called the transformer, and this thing was a total game changer. Its design was unique because it could understand the connections between words over really long sentences and paragraphs, something older models were terrible at. And second, the data. They fed it something called the books corpus.
And you might be asking, why books? Well, it's because unlike a lot of other data sets that were just a jumbled mess of random sentences, this collection of over 7,000 unpublished books gave the model long flowing passages of text. This is what taught it how to track relationships, characters and ideas across pages, not just in a single sentence. It learned how stories and complex arguments actually unfold over time. That's a skill that was totally missing before.
Okay, so they had the plan, they had the tools. But of course, the billion-dollar question was, did it actually work? Could this one generalist model, after being fine-tuned, really outperform the old-school, highly specialized models that were custom-built for every single task?
And the answer was, oh yeah, a resounding yes. This model, which they called the Generative Pre-Trained Transformer, or, GPT for short, it set a brand new state-of-the-art record on 9 out of the 12 language tasks it was tested on. It was beating models that had been painstakingly built for those very specific jobs.
And this number right here, this really shows you the scale of the improvement. I mean, we're not talking about a tiny little bump. On this one notoriously difficult common sense reasoning task, GPT got an 8.9% absolute improvement over the previous best. In this field, that is a massive, massive leap forward.
And if you look at the results here, the pattern is just crystal clear. It didn't matter if it was common sense reasoning, answering tough questions from high school exams, or even just judging if a sentence was grammatically correct. This one, single, generalist model consistently wiped the floor with the specialists. This was the proof. It was definitive proof that a broad general education was way more powerful than narrow specialized training.
So the success of this paper, it was way more than just a new high score on some academic leaderboard. It was a fundamental shift. It kicked off a whole new way of thinking about building AI, a new paradigm that, well, we're all living in today.
And this timeline here, it just shows you how fast things went from 0 to 100. That simple two-step idea from 2018, it directly led to an absolute explosion of progress. Just a year later, we get GPT-2, which showed off this incredible generative power. Then bam, GPT-3 in 2020, and finally, ChatGPT in 2022, which put this incredible tech into the hands of millions of people just like you and me.
You know, when you read the conclusion of that original paper, it's pretty clear the authors knew they were sitting on something huge. They hoped their work would open up new research into this kind of learning, and man, were they right. They didn't just build a better model. They literally gave the entire field a new roadmap to follow.
So, what's the big takeaway here? Sometimes the biggest breakthroughs don't come from making things more complicated. They come from a simple, elegant solution to the right problem. This idea of pre-train and fine-tune unlocked a wave of innovation that's still getting bigger and faster today. Which kind of just leaves you wondering, right? What's the next simple idea that's going to change everything? All over again.